Hello everyone and greetings to all. Today our team is presenting a C++ project and we are preparing its video. And this video is all about our mini project of C++ and our topic is number system conversion using C++. So let's see what it's all about. So actually this is our C++ mini project and our aim is to create a C++ programming language which implements whole number system conversions. So actually it is a number system conversion program which will convert all the number system to different forms. So and the abstract of this program is like program for converting into various number system, that is hexa, decimal, octal, binary, and interconversion of these numbers will be there. So we have used some basic concept of linear data structures, array and condition statement like if else, if ladder, switch statement, etc. And we have used the concept of static functions and variables to make the program more efficient. So actually if we discuss the problem statement of this program, like why we have chosen this project or why we have chosen this topic, it is because when you will go to conversion of these octal and hexadecimal, these kind of numbers, you will need a lot of manual calculations, or if you use some scientific calculators also, then you will need to learn the how you have to convert, or how you have to use the all the operations inside the calculator. So what our team has come up with an idea so that we can create a project which can actually help students and other persons so that they can apply this program to their real life. And it is pretty well easy, and we have used C++ language as we software use this code blocks 13.12 with GNU GCC compiler, and it is an open source software, so you can actually get it from the internet. So over to Wangel.
Hello, this is Wangel Lama, and now I'm going to explain you about the description about our project of C++. So we have written a program for converting the various number systems, that is hexadecimal, decimal, octal and binary, into those other number systems. So we have used basic concepts of linear data structure, basically known as the array concept, and we have used statements, decision-making statements like if, else and switch statements. So we have used the concept of static functions also for initializing the variables. So yes, the number systems that we have used are binary, which consists of 2 digits 0 and 1, octal, which consists of 8 digits 0, 1, 2, 7, and decimal, which consists of 10 digits 1 to 0, 1 to 9, and hexadecimal, which consists of 16 digits 0 to 9 and then 8 to F. And yes, we have done these following conversion in our program, that is binary number to these octal, decimal and hexadecimal, octal number to binary, decimal and hexadecimal, decimal number to binary, octal and hexadecimal, and hexadecimal number to binary, octal.
Hello everyone, my name is Victor Joseph and I have made the documentation and structure of this program. So let's see the code. So I have made these function prototypes and its return type is void. So this is for binary to decimal, binary to octal, binary to hexadecimal, then decimal to binary, decimal to octal, decimal to hexadecimal, then octal to binary, octal to decimal, then octal to hexadecimal, and then hexadecimal to binary, hexadecimal to decimal, and then hexadecimal to octal. So let's see the main function. So there's the documentation part as C++ mini project number system conversion calculator, and these are the team members along with the registration number. So where I have used some while loop, and these are the output statement. Like if you want to go for binary to other, then you have to press 1, and then I have to use a switch case, and then I have to use nested switch case. So like if you press 1, that is a binary to other, it will go in here and it will show you these options. Like this will be the output message to the user, and then again it will ask the user to press any of these. So either 1, 2, 3, 4. So again if I press like 1 binary to decimal, it will go in here binary to decimal and it will go to the respective function. So that's how it works, and I have done this for all the remaining things. So I'll show you that thing. So if I press 2, that is for decimal to other, it will go in this case, and then again it will show you these things. Then 1 decimal to binary, 2 decimal to octal, 3 decimal to hexadecimal, and then 4 hexa. So you'll be having these things, and then you have to press any of these in order to get the output. And then if you press 3, that is an octal to other, it will go in this case, and then again it will show you the output message. So one is for octal to binary, two is for octal to decimal, three is for octal to hexadecimal, and four is for exiting from the loop. So again you have to press any of these in order to get the output, and then if you press so that is for hexadecimal to other, then it will go in this case, and then again it will show the output message that press 1 for hexadecimal to binary, 2 for hexadecimal to decimal, 3 for hexadecimal to octal, and then 4 for exit, and then you have to press any of these numbers in order to get the output. And then at last if you press 5, that is for exiting from the loop. So that's how you do this program. That's what I did. So thank you so much, and now over to
Hi, this is Ebenezer. Here I am going to explain the function which I use in this program. I create a function to convert the binary input to the decimal number. Here I declare the necessary variables here, and I'm getting the input of the binary numbers, and using do while iteration I'm converting the decimal number to the binary number using this logic, and I am printing the decimal number. Over to Gagan.
Hello, I am Gagandeep. This is the program for binary to octal and binary to hexadecimal. First, we'll see the program for binary to octal. Here, I have declared the necessary variables for input, and here I have entered the statement for for entering the binary number. And here, this loop is for splitting the binary number into three groups, and it would accept binary digits up to 15 bits. And at the end of this program, it will show the converted binary number into octal number. And for binary to hexadecimal program, this is the declared variables, and here is the input for the binary number, and there are few characters variables which are declared here. And for this for loop is for splitting the binary number into 4 groups, because here we are using 8421 rule, and it would accept binary digit up to 16 bits. And here we are printing the hexadecimal number as output. Now I'll pass it to Paul.
Greetings to all. My name is Paul John, and I'm here to explain the implementation of the octal to other conversions. I've totally made 3 functions. Let's move on to the first function. The first function is to convert octal to binary, and in this case, the first conversion is the octal to decimal. This code has been used earlier in the functions. I'm not going into further details. And after converting the octal to decimal, the decimal is converted to its equivalent binary. Now, moving on to the second function, the conversion is from void octal to decimal. Same thing has been done earlier, and the code is the same. And next, the third function is octal to hexadecimal. In this case, the conversion happens from octal to decimal, and then the decimal is converted to binary. The octal to decimal conversion, it's been used earlier, it's quite familiar, I'm not going into further details. And then the decimal is converted to binary. Even the same code has been used earlier. Now, to convert the binary to hexadecimal, we'll have to group the binary into equivalent 4-bit groups. That is, each group consisting of 4 bits. You're grouping into 4 because of the speciality of hexadecimal. Now, I have done this using if-else statements and 4 loops for individual conversion of each group. The speciality of hexadecimal number is that it starts from 0 and then it goes till 10, and after that it's like A to F. So to implement this, I have used the concept of ASCII values. I convert the integer, I add the integer with its respective ASCII value. That's for 1 it's 49. Similarly for capital A and all that, according to the ASCII value. And after that, I store the added value into C. That is a character variable. Now after doing this, we'll be able to get our proper value. Now I've done this over here, and that's about it. Now let's move on to the next conversion. So I Like I'm calling Harry.
Hello, this is Anahat Srihari and I have created three functions for conversion of decimal number to binary number, and decimal number to octal number, decimal number to hexadecimal number. So let's see the code. Here it first asks the user to enter the decimal number and takes the input in denum. In this, using this do while loop, I convert decimal number into octal binary number by this formula. Remainder is equal to number divided by 2, sum is equal to sum plus 1 into remainder, and number is equal to number by 2, I is equal to I into 10. By using this loop, we convert decimal number into binary number and it is displayed by this cout statement. And by for the next decimal to octal, it again asks the user to enter the decimal number which we have to convert in octal. In the same way we have converted binary. I have converted decimal to octal, but just the difference is we are divided by model 8 and modulus 8 here. So in same way, by using do while loop, I have done this and the output is shown here. That is the octal number of the given decimal number is shown. Now moving on to decimal number to hexadecimal number. First, it takes the input from the user as in the above also, and then in the same way using do while loop, it first converts it into binary number and then it splits the binary number into 4 parts, and that 4 parts I have split it into this 4 for loop using that, and then we use 8421 logic in that. In that way, it is converted into hexadecimal, and then here the hexadecimal number is shown after the conversion. So this was the functions which I made. Thank you, and now over to Tanmay.
Hello everyone, this is Tanmay. My contribution to this project is that I have made conversions from hexadecimal to other number systems. So first we'll check out the function hexadecimal to binary. Its return type is void, and here I have created a character array, and here I have created an integer array, and I have declared few variables. So first here I am getting the input of hexadecimal number, and then inside n I am storing the string length of that hexadecimal string. So as you can see here, using for iteration, I'm copying the hexadecimal. I'm copying the elements which are present in hexadecimal array into an integer array. Actually, I'm typecasting it. So, using for iteration and pointers concept. So after that, here I'm actually converting it to its original integer values from their ASCII code values. So when I typecast a character array into an integer array, then whatever values will be stored into an integer array will be it would hold the ASCII value for the character numbers, for the character input. So after that, here I am just converting it into decimal number. So after I have decimal number with me, I am converting that decimal number into binary number, and this is how hexadecimal to binary function works. Now we would check out hexadecimal to decimal function. The return type of this function is also void, and here also I have created two arrays and I have declared few variables, and this is here we are following the same procedure
as I have explained you above, and we are converting it into decimal number, and then we are printing it. In hexadecimal to octal, first I have converted I'm getting the input of hexadecimal number, and after getting the input of hexadecimal number, I'm converting it into octal number. First I'm converting that hexadecimal number into decimal, and then I'm converting that decimal number into octal. So that's all for this project. Let's check out the output of our project. So as you can see that this is the documentation part. Here it's asking the user to enter the choice. For example, user entered the choice as 1. So in 1 it would show that uh, it would go into the first case of the switch, that is binary to decimal, binary to octal, binary to hexadecimal, and then fourth one is the exit. For example, user entered 1, then it prints that you have chosen binary to decimal. Then it asks the user to enter the binary number, and then it would convert it into decimal. Then again here, as you can see, I have got the choice 2, that is binary to octal. So it would get binary number, and it would print an equivalent octal number for this binary number. Similarly is for binary to hexadecimal. So as you can see, if you press 4, it would exit from this iteration. And then in binary to and then we are choosing 2, that is decimal to other. Again we are getting input of decimal number, and then we are it is being converted into binary number. If we enter 2, then decimal to octal will take place. Decimal number will be taken as an input, and it would return the octal number. And for decimal to hexadecimal, it would take the input of decimal number, and then it would give the output for it would take the input for decimal number, and then it would give the output for hexadecimal number here. So, and 4 for exit. And similarly it is for octal to other also. First one is for octal to binary. As you can see here, here we have taken input as 7, and then it has converted it to its equivalent binary number, and then it has taken the input as 2. It has taken the choice as 2, and then it has taken the input for octal number as 5, and the equivalent decimal number is also 5 as well. Then it has get the input for choice, that is 3, and then again it asks the user to enter the octal number. So you can see octal number 6 it's 6 only in hexadecimal number. So again it exits from this program if you press 4. Again it's asking the user to enter the choice. Now this time we have entered hexadecimal to other. In hexadecimal to other number system conversions, in choice 1, for example, if a user entered hexadecimal number as A, then it would print 1010. If user entered his choice 2, if he entered as hexadecimal number as C, then it would print its equivalent decimal number. And if user entered as choice 3, then he has to enter hexadecimal number, and he would get desired output in octal number. So as you can see that the hexadecimal number E is octal number 16, and it would press 4 for exit. So again if you press 4, it would exit. If you press 5, if you press 4, it would keep on running this iteration. If you press 5, it would exit. So that's all for this project. Over to Ashish.
So finally guys, you have seen that how we made this program, and I hope that you guys learned many things from this video presentation, and we have explained many things in this mini project video, and we just took the simple topic from the everyday life, and we just tried to make it a simpler to other people so that they can use this program in effective way. So let's get to the conclusion. The concept we have applied here is linear data structure array, static variables, looping statement, branching statement, nested menu driven module, and basic arithmetic operations. So these are just basic concepts of C++, and we have just used in this program to make it simpler and adaptable to the user, so that user can enter the input and can get output easily. And then we have some advantages of this mini project also. Let's get to it. The calculation we have implemented using our program is of complex nature in the real world. As I already told you, like when we used to apply these kind of things in our everyday life, either we have to use a manual calculation, or we have to get into the tough process or operation of the scientific calculator. Our program make this complex nature of this calculation more simpler and more efficient. So this program actually deals with that. We have made in such a way that it is user friendly, and you can basically develop this program to an app, or you can just spread this app to many persons so that they can use it. And this program is actually helpful to the students, so they can perform their logical calculations here in this program. And this code is adaptable and versatile, as I told you. That is, it can be implemented in all high-level language with necessary modifications. So we can also do, as we all know, that C++ has a higher advantage over the C, and it is basically a most adaptable language we all know so far. So basically we can give a good modification to this program, and we can modify it at a high-level language also. And so these are group members, and thank you very much for watching this video. Hope you liked it. So please do like and comment your doubts, and if you have more suggestion, please do comment, and please share this video. And this video and this mini project actually made under the guidance of our teacher, our C++ teacher, Miss Leela ma'am. So thank you very much, ma'am, for your guidance also. So guys, here I am Ashish, Ramesh with my team, and we all are signing off this time. Thank you and have a nice day.
Ashish.